Hey guys, in this video we are going to be reviewing exponential functions. In math, we know that an exponential function is a function of the form f of x equals a times b to the x power, where we know that f of x just means y. So, previously, we've dealt with functions where the exponent is usually a number. And when I say that, let's just look at this. Y equals 2x squared. Usually that small number, that exponent, we've been dealing with quadratic functions where the exponent is a number. But now, when we're dealing with exponential functions, the exponent will now be a variable and the variable will be x. And so, an important thing to know about exponential functions is if you have an exponential function such as, let's look at this one, f of x is equal to 3 times 4 to the x power. Just like other type of functions as linear and quadratic, the number that does not have a variable attached to it, the number that is constant, that is going to be your y-intercept. So in an exponential function, the number that's before the b, or it doesn't necessarily have to be before the b, it can be just really the number that does not have a variable attached to it, that's going to be your y-intercept. That's going to be your y-intercept, because if we look at y equals mx plus b, the m has a variable attached to it, but the b doesn't, and that's our y-intercept for a linear function. And then if we look at a quadratic function, y equals ax squared plus bx plus c, you would notice that the a has a variable attached to it, the b has a variable attached to it, but c doesn't. So that last number in the quadratic function would be the y-intercept. So it's not necessarily the last number in a function is the y-intercept. It's the number that does not have a variable attached to it that will be considered the y-intercept. Okay. Another important thing about exponential functions is that they can describe growth and decay. Growth and decay. And what that means is if we graph an exponential function and it rapidly increases, it can be described as growth. And if we graph an exponential function and it rapidly gets smaller, as x increases, it rapidly drops, that can be described as growth. As decay. As decay. So let's look at some examples here. We have this exponential function right here. Y is equal to 1/3 to the x power. And we have these input values. Let me make a note here. We have these input values. Our x is our input, and then we're going to get our output, which is going to be our y. And then once we have our input and our output, we can write our ordered pair. So how we would do that is if we have this function, we're going to take this function 1/3, and instead of writing that x, this x is the one I'm talking about, we're going to substitute it for whatever value it tells us that x is. So in this case, x would be -3. And we're going to solve this to get our output for the y. So I'm going to bring up a calculator here. And I'm going to type in parentheses 1 divided by 3, all raised to the -3rd power. And I'm going to hit enter. That's going to give me 27. So I'm going to put 27 for my y. And that means that my ordered pair here would be -3, 27. Okay? And so I want you to pause this video and see if you can fill out the rest of this chart here. And you can unpause the video to see if you got the correct answers. All right, let's take a look at it. So if I look at this next one here, we have y is equal to 1/3, all raised to the -2nd power. This one will be y equals 1/3, all raised to the -1 power. Y equals 1/3, raised to the 0 power. Y equals 1/3, raised to the 1st power. Y equals 1/3, raised to the 2nd power. Y equals 1/3, raised to the 3rd power. Okay. You can continue to do these the exact same way that I just taught you by doing parentheses. 1 divided by 3, all raised to the -2nd power. That's going to give you 9. And now I have an ordered pair of -2, 9. 1 divided by 3, all raised to the -1 power. Hit enter. 3, and that's going to give me -1 and 3. Or if you can remember, because if you guys remember, in each type of function, we evaluate linear functions, quadratic functions, and exponential functions all the same. You can do this type of problem here and fill out your entire chart by doing the substitution way that I just taught you. Or you can think about, well, I have an equation right here that's solved for y. Well, where do I go on my calculator to put an equation solved for y? I'm going to go to y equals here, and I'm going to type in exactly what I see. And I see parentheses. I'm going to hit alpha y equals and this n divided by d to bring up those two boxes. You do not have to do it that way. You could have just did 1 divided by 3. I just like to make it look exactly as I see it. And then I'm going to raise that to the x power. You're going to type in what you see right here, your original problem in y equals. And now you're going to check that table, because you can check these values on your table. So you're going to hit second graph to bring up your table here. And to find out whenever x is -3, I'm going to scroll down to -3. I see that my y is 27. That's what we found. When x is -2, my y is 9. When x is -1, my y is 3. So when x is 0, whenever x is 0, my y is going to be 1. So I can go ahead and write my order pair 0, 1. Whenever x is 1, my y is going to be 0.3333, a whole bunch of 3s. I'm just going to make a note of that because I really want it in fraction form. So I'm just going to make a note, 0.3, and I'm going to write this line on top to let me know that it's repeated. And when x is 2, my y is going to be 0.1 repeated, 0.1 repeated. And then when x is 3, my y is going to be, I'm going to write that number right here because it's kind of big. 037 037 03704. That's what my y would be when x is 3. So I can go out of my calculator here, and I want to convert this 0.333 into a fraction. So to do that, you have to just put a whole lot of 3s. If you don't, you will get the wrong fraction. So now I'm going to hit math, number 1 for fraction. I'm going to hit enter, and that tells me that that's going to be 1/3. So my y would be 1/3, and my ordered pair would be 1, 1/3. This one right here, where my 1 is repeated, 0.1111. Just gonna write a lot of them. Gonna hit math, fraction, and then enter. And I know that my y is gonna be 1/9. So my ordered pair would be 2, 1/9. And this fraction right here, this decimal, I'm sorry, 037 037 03704. Math, number 1, and enter. It's going to give me 1/27. So I know that my fraction would be 1/27, and my ordered pair would be 3/27. So I have filled this out, and now you know how to either substitute it or check the table to fill out your chart there. This question down here asks, well, what is the y-intercept? Before I actually graph anything, I can tell what my y-intercept is, because remember, when your x is 0, your y, that's going to be the point that the graph crosses the y-axis, because it's not going to touch that x-axis. So we know that our y-intercept is going to be 0, 1. That's going to be our y-intercept. Let's graph it over here. Let's graph what we can graph. Some of these order pairs, we won't be able to graph them because either we don't have enough space to graph it, or I wouldn't ask you to graph a fraction. So let's just plot the points that we can actually plot. And it looks like we can only plot these 3 right here. We can plot these 3. So I'm going to go to -2 on the x-axis, and I'm going to go up to 9. And I'm going to put a point there. So -2 up to 9. I'm going to put a point there. And then I'm going to go to -1, and I'm going to go up 3, put a point there. And then I'm going to put my y-intercept, which is 0, 1. So I'm going to put a point there. And I can already tell that this graph is going to describe decay, because it's going to get smaller as the x increases. And your graph should look something like this. Now let's go to our calculator here just to see if I did draw this right. We already have it keyed in whenever we did our table. So I'm just going to hit graph here. I'm going to zoom it in some so we can see it. And if you look, graph on the calculator right here is going to be blue. Looks kind of similar. You know, my graph over here isn't to scale, but very, very similar. All right, let's go on to this next slide here. We have another function here, and the function is going to be y equals 2 to the x power. I want you to pause this video, and you can either work this one out using the substitution way by substituting your x with whatever x value and telling me what your y is, or you can go right to your calculator and you can check that table for the function y equals 2 to the power of x, and you can see, and you can go ahead and fill out your table. So pause this video now and then come back and tell me if you've keyed in your chart the right way. All right, so I'm just going to go ahead and I'm going to write, I'm going to write out, if I did it the substitution way, how it would look. All right, so remember, we can always just go to our calculator here, and we can do 2 raised to the power of negative 3. That's going to give me 0.125. I want that to be a fraction, so I'm just going to go ahead and turn it into a fraction. That's going to be 1/8. 1/8. Did I do that right? 2, -3. Yes, 1/8. So my ordered pair would be -3, 1/8 for my y. And I have 2 raised to the -2 power. Oh, I'm sorry, I didn't do that right. 2 raised to the -2. It's going to give me 0.25. We're going to change that into a fraction. Math, number 1 for fraction, 1/4. So my ordered pair is -2, 1/4. Okay, I have 2 raised to the -1 power. That's going to give me 0.5. It's going to give me 0.5. If you see, I'm getting bigger. I'm increasing. My numbers are getting bigger in my function here. So I'm going to have 0.5. I'm going to change that to a fraction. Math, number 1 for fraction, enter. That's going to give me 1/2. My order pair will be -1 and 1/2. Now I'm going to go to the next one. 2 raised to the power of 0. That's going to give me 1. So I know that my y-intercept is going to be a positive 1. So I can go ahead and write what my y-intercept is, because that x is 0. That's how I know that that is my y-intercept. X is 0. Okay, let's do 2 raised to the power of 1. That will give you a positive 2. So I have a 0.12. 2 squared, give you 4. Have the 0.24. And then 2 raised to the power of 3. It's going to give you 8. So I have a 0.38. Now, just like the one from before, I would not ask you to plot points that have a fraction, so I'm not going to worry about those. I'm just going to worry about the ones that I can actually put a point on my graph for. So I have my y-intercept 0, 1, so I'm going to go ahead and I'm going to put a point there. I have 1 and 2, going to go over to 1 and up 2. I have a point at 2, 4. I'm going to go over to 2 and up to a positive 4 on the y-axis. And then I'm going to do my last point, which is going to be 3 and 8. Go over to 3 and go all the way up to 8. Put a point there, and now I can just connect my dots here. And we're going to check to see if our graph is pretty similar to the one that you would graph on the calculator. Let's bring that up smaller here. Let's bring it up a little smaller. And our function, our original function was y equals 2 to the x power. So I'm going to go to y equals, clear that out, and I'm going to do 2 to the x power. And I'm going to graph that to see what it gives me. I'm going to zoom in so we can see it a little bit more. But it looks like we drew our graph pretty good in the right way. But from this exercise, I really wanted you to understand that if you're given a graph, and it gives you answer choices, let's say, and it asks you which one of these functions matches that graph. If you have if you have functions that's already solved for y, g of x, remember, means y, f of x means y. It's just a function of x. If you already have equations that solve for y, you can just go right to your calculator and you can graph those functions and see which one matches up to the graph. Or let's say you could actually pick out some points on that graph. When I say pick out some points, like these points we just put, if you can pick those points out, you can also put your equation into y equals, and you can check the table to see if these points are included on the table for the function that you're checking. That makes sense. All right, let's move on here. Let's move on. This time it's giving us a table and it tells us to find the graph for each table and then to graph it. Okay. We can do this a couple of ways here. Well, we can go ahead and we can graph it if we would like. And, you know, you can graph it by just go ahead and plotting your points. I could plot this point right here, 0, 4. Put my point right here. As a matter of fact, let me make it a little bit thicker. Put my point right there. I can graph this point, 1, 8. Go over to 1. I can go up to 8. Put a point there. 2 and 16. And 3 and 32 doesn't look like I can graph those, but I'm going to just attempt to kind of ballpark it, I guess. Go over to 2. We're going to go up to 16. Let's just say 16 is right here. And then we're going to go over to 3. I'm going to go all the way up to 32. And we're just going to say 32 is going to be somewhere right there. Not to scale at all. Not to scale at all. But the important thing about this is if you have a table, guys, if you have a table, you have to remember when you see a table, the first thing that you have to think, especially for your calculator, is stat. You have to think stat. We're dealing with exponential functions. So the only step that's going to differ from your linear and quadratics when you have a table and you input it into your calculator, the only difference is going to be the option that you select. And that option that you select should be 0 exp reg. Exp reg. It's going to give you an A and a B, and you have to write that equation in the form y equals AB to the x power. AB to the x power. So with that being said, let's go ahead and let's look at our calculator here. Once you have your calculator, you want to go to stat. You have a table. You want to go to stat and you want to hit enter for edit and you want to put in your values. Remember, X is for L1, Y is for L2. Let's go ahead and let's key in our numbers now. So we have 0, 1, 2, and 3. Go over to L2, and you're going to have 4, 8, 16, and 32. They're doubling for exponential functions. 4, 8, your y values double as your x increases. 4, 8, 16, and 32. I'm going to hit stat again. Remember, these are the steps to finding your equation. Go over to calc, and then you can either hit 0. I'm going to actually scroll so you can see the different options. 0 right there. We usually use 4 for linear functions, line reg, 5 for quadratic functions, and then now we're dealing with exponential functions. We're going to use option 0. Going to hit enter, and then you're going to hit enter 5 times. It's going to give you an A and a B. A and a B, just like I said. So on that, with the A and the B that you found, you are going to put those numbers into your equation. You have an A that equals 4 and a B that equals 2. So I'm just going to substitute my numbers in right here. And it's very important that you, whenever you write your answer, you want to put parentheses around your B. Because if not, it's going to look like that your numbers go together. Let me show you here. You have y equals 4, 2 to the x power. If you do not put parentheses, that looks like 42 raised to the x power. That's why it's important to put your B in parentheses. So we have 4 times 2 raised to the x power. Raised to the x power. So now, from there, I'm going to go back to my calculator here, and I'm going to go to y equals. And I'm going to graph that equation that I just found. So, and you want to write it exactly as you see it with parentheses and everything. 4 times 2, all raised to the x power. And I'm going to hit graph there. And you see how that it went up very quickly. It went up because it's showing growth. It's showing growth. It started here. And then it went up, crossed through the y-axis at positive 4. And continue. It's going to continue to go all the way up. It's going to continue to go all the way up. All right. Let's look at this one. I want you to pause this video and see if you can find that equation before I actually go over it right here together. All right. So remember, on your calculator, you want to go to stat. You want to go to stat. You want to hit edit. And you want to put in your table. So I am going to, let me delete out everything in this one. And then remember, L1 is for X, L2 is for Y. I'm going to put 0, 1, 2, and 3. Go over to my L2 column. I'm going to put 8, 4, 2, and 1. And then I'm going to hit stat again. I'm going to go over to calc. I'm going to hit 0 for exp reg. I'm going to hit enter. And it's going to give me A and a B. That's all I need to focus on, that A and that B. The A says that it's 8 and the B is 0.5. Now, you can write your equation like this if you would like. 8 times 0.5 raised to the x power. But you don't want to forget, if you have answer choices and you don't see a decimal, if you see fractions, then that means that they want you to convert this to a fraction. We know that 0.5 is just half, so we know it's going to be 1/2, but let's show you on the calculator. 0.5, you want to hit math, number 1 for fraction, and enter. And you see that this 0.5 will be 1/2. So you could also write this same problem as y equals 8 times 1/2 all raised to the x power. Same thing, just wrote it with the fraction. Okay, so now let's try to graph it here. Let's see if we can graph some of these numbers first. So we have a y-intercept of 8, and I know that we have a y-intercept of 8 either by knowing that once you find your equation, the number that does not have a variable attached to it is going to be your y-intercept, or you could have looked at your table to begin with and saw that this x is 0. So whenever x is 0, that's going to be your y-intercept. So I'm going to put a point at 0, 8 right here. Let's make that point bigger. 0, 8. Then I'm going to put a point at 1, 4. Go over to 1, up 4. I'm going to put a point at 2, 2. Over to 2, up to 2. And I'm going to put a point at 3, 1. Go over to 3 and up 1. And we can tell that this is going to be decaying. Is going to be getting small as x increases. It's going to be getting smaller. The y will be getting smaller as x increases.